Yes, and I welcome you back, guys, for our second lesson. I do believe you went through the first lesson, you got the introduction. So here is going to come series of these lessons from each other. And here is the first equation where we are going to solve first order differential equations. Now, under first order differential equations, we look at three types. And the first one is separable differential equations. And when they are separable, it means that by separating the variables, the ones which are the same, you put them one side, yeah, like that. So by separating variables, you can solve these equations. You can solve these equations very easily. Then we have those ones which are non-separable. When they are non-separable, then they can be either exact or inexact. Okay, so regardless, we shall look at, of course, how we test for the exactness. But in case you find a differential equation which can't be separated, or whose variables can't be separated, first test for exactness. If the exactness exists, then you integrate the function that was differentiated to give the terms on the left-hand side and the right-hand side. We shall see this. Then if inexact, we need first transform it exact by using an integrating factor, which makes it exact. And then we continue as in one, meaning we shall integrate the function that was differentiated to give the terms on the right-hand side and the left-hand side. Then the third one is homogeneous. There is, for the case of homogeneous, these differential equations are solved by use of change of variables, and that is, for you to change variables, you have to substitute y as vx or y as ux. So without wasting time, we shall look at separable differential equations. Yeah. Separable differential equations, that is where we are starting from. My screen is misbehaving. Yeah, separable differential equations. Now, for separable differential equations, if I suppose a function f of y dy dx is equals to g of x yeah, if I suppose this function, when I say separate variables, you can multiply, you can of course multiply so that you have f of y dy is equals to g of x dx. I have separated variables. So this is followed by integration. So another step would be integrating f of y dy is equal to the integral of g of x dx. Then the steps will be following as we shall see. So without wasting still any single minute, let's look at examples. Solve that is number one, solve the equation 1 plus cos 2 theta dy d theta is equal to 2, hence find a particular equation given that y is 1 when theta is a quarter pi. Yeah, for this case, what we need to do, we need to rewrite this expression. We are having 1 plus cos 2 theta. Then they have said dy d theta is equals to 2. So what we do, multiply by d theta. So if you multiply by the theta, you have 1 plus cos 2 theta, then dy is equals to 2 d theta. Now, by having this, of course, you cannot do this. Yeah, we cannot do this when this side we have dy and d theta. We have to separate these variables, implying that if we divide through, it will be dy is equal to 2 over 1 plus cos 2 theta, then everything d theta. Yeah, so so still one can say this is the same as dy is equal to 2 over yeah, we know that it will be 1 plus cos 2 theta. One can establish cos 2 theta as 2 cos squared theta minus 1 for easy integration, then d theta, which still I can write as dy is equals to 2 over 2 cos squared theta d theta, because a 1 and negative 1 will go. So I have my dy is equals to 2 will go. 1 over cos squared is sec squared theta d theta. I integrate both sides. When integrate dy, you get y. When integrate sec squared theta, you get tan theta. Then of course, plus a constant of integration. What you've gotten here is what we call a general equation or a general solution, but we need a particular solution. For us to find a particular solution, we need to substitute for this arbitrary constant of integration c. And how do we do that? We need to first substitute for the values given for y and theta, so that we first get the value of c, then we substitute the value of c into this equation, and we get what we call a particular equation. So how do we do that? I will come and say when y is 1, theta is a quarter pi, substitute, so it means that 1 is equal to tan pi over 4 or tan a quarter pi, then plus a constant. We need to understand that for this case, tan pi over 4 is 0, so rather is 1, because this tan 45 is 1 minus 1 0, so our value of c is equal to 0, meaning that if c is 0, if I substitute here to get my particular solution, it will be y is equals to tan theta plus the value of c, which is 0. Therefore, my particular solution is y is equal to tan theta. That way, you will have solved. You'll have solved the we shall have solved the differential equation. Shall have solved the differential equation. So let's have number 2. Solve solve the equation dy dx is equal to the square root 1 minus y squared. Then here the conditions are y of 1/6 pi is 0. For this case, we need to separate the variables. We need to separate the variables, and we shall have dy dx is equal to root 1 minus y squared. So we can say dy multiplied by dx both sides is equal to the square root of 1 minus y squared. Then dx, we separate variables further, so you'll divide by this so that the dy comes this side, and the root 1 minus y squared this side is equal to dx. Then the second step after having separated the variables is to integrate both sides. So we shall integrate dy over 1 minus y squared is equal to the integral of dx. When you integrate this, you need to realize that here we shall apply sign substitution. Under integration, I covered this work. Yeah, I covered this work of integral. So when you integrate this, you get sine inverse of y. If it is a bit confusing, I would members recommend that you check on my playlist. You get where there is sign substitution of integration. You can get all the details about this. When you integrate dx, you get x plus a constant of integration. Now, remember they say that y of this is 0. It means that this is the x, y of 1/6 pi. So this is the y of x is 0, meaning that y is 0, x is 1/6 pi. So we are going to substitute for y is 0 when x is a 1/6 pi. It would mean that we're going to have sine inverse of 0 is equal to x, which is pi over 6, and plus a constant c. This is 0, so it means that c is equal to negative pi over 6. So if c is negative pi out of 6, it means that if we substitute for the value of c to eliminate an arbitrary constant, we shall have the sine inverse of y is equal to x minus pi over 6, implying that if this is a sine inverse of y is this, then it means that y is equal to sine x minus pi out of 6. It's like when one says that y is equals to 2 point, okay, it's like when one says sine y is equals to 0.2. Then what about y? You would say sine inverse of 0.2, meaning if they have given you sine inverse of 0.2, when you introduce sine, this side will be sine y, and here the sine inverse will go. So this is what we are having. Yeah, then from here, we are going to do number 3. You're going to do number 3. Whereby given that dy dx plus xy cubed is equals to 2xy, and that x is 0 when y is 0, and that x is 0 when y is 1, sorry, when y is 1, show that y is equal to the square root two e squared over e squared plus 1 when x is equal to 1. It looks too small, but it's a very big number, as it can take us. Yeah, as it can take us somehow far. So let's attend to it and see. For this case, still, we can easily separate the variables. And it is where we are having dy dx plus xy cubed is equals to 2xy. It would mean that dy dx will be equal to 2xy minus xy cubed. Yeah, so it means that dy dx is equal to, if I start separating variables, it will equal to, here we can factorize out xy being common, so I will say xy into this is a 2 minus, here we are left with y squared. Yeah, so dy dx, because separating variables may still be challenging. Yeah, I don't want us to be challenged here, so it is xy into this one. We can make it a difference of 2 squares, but to make it a difference of 2 squares, these 2 also must be under, it must be squared, and it shouldn't change from being 2. So that's why I'm saying that we call it root 2 squared, then minus y squared, so that our dy dx is equal to xy xy. Then here now this one has been made difference of 2 squares, so we shall say xy into root 2 minus y times root 2 plus y. Yeah. So now here, this is the difference of 2 squares. We subtract and then we add. Now, after reaching here, we can separate the variables. We can separate the variables whereby I will have dy over, I divide by the contents of y. So we shall have y, then root 2 minus y, then root 2 plus y. Yeah, so this is equal to x dx. I've separated variables. Now, students who attended my work on YouTube, I think you really saw how we were using the partial fractions to overcome such issues. If not, please, I still recommend. Because I told you that this topic is a continuation of integration and differentiation. So we shall let so we shall let our 1 out of y into root 2 minus y root 2 plus y to be equal to, we can say a1 over y, we shall look for the value of a1, then plus a2 over root 2 minus y, then plus a3 over root 2 plus y. Now, looking at this, we need to solve for the values of a1, a2, and a3. So when you take the LCM, it means that we shall have 1 will be equivalent to, when you are using equivalent, there must be triple signs here, but I can say 1 is equal to a1 into root 2 minus y times root 2 plus y plus a2 into root 2 plus y, then times y, then plus a3 into root 2 minus y, then times y. So we need to solve for the values of a1, a2, and a3. So if we put the value of y as 0, yeah, if we put the value of y as 0, it means that this one will become 0, the whole of this will become 0, and the whole of this will become 0, and there we can get the value of a1. So putting y as 0, we shall get the value of a1 as, because if y is 0, it means that this is 0, this is 0, this is root 2 times root 2, which is 2. So we shall get a1 as a half. Then if we put y as if we put y as root 2 or as negative root 2, if we put it as negative root 2, of course this one will go and this one will go, we can get a3, yeah, but you put y as negative root 2. When y is negative root 2, it means that here is a1 into root 2 minus negative root 2, but here is already 0. Y is negative root 2. Y is negative root 2. So this is 2 minus root 2. This is also 0. Yeah. So we shall get, this is 0, even this is 0, but this is root 2 minus negative root 2. We have root 2 minus negative root 2, which is 2 root 2 a3 is equals to 1. Yeah, so we shall get, you can try solving so that we don't make any mistake. Then if we put y as root 2, we substitute y as root 2, it will be root 2 minus root 2, the whole of this will go. Then here it will be root 2 minus root 2, the whole of this will go. So let's try solving it so that we don't bring in issues. So if we put y as √2, we shall have 1 this side is equal to √2 minus √2, that is 0. So the whole of this has become 0. √2 minus √2, the whole of this has 1. So by putting y as √2, we shall get positive. Rather, we shall have here now. So we shall have a2, 1 is equals to a2 into √2 plus √2 times √2. So this is √2 plus √2, that is 2 √2. So we have a2, 2 √2 times √2, that is 4 for a2. So implying that a2 is equals to a quarter. Then for this value here, when you substitute negative √2, you're going to get a3. And our a3 is going to be negative it will be negative a quarter. Yeah, it will be negative a quarter. A3 will be negative a quarter. So now there are these values that I'm going to move, bring here, and then integrate so that I get this side. Right. So remember, we are proving, we are just looking for is have not come in yet. So implying that our 1 over y √2 minus y √2 plus y is the same as the value of a, which we got as a half. So it will be 1 over 2y. Yeah. Then plus, of course, the value of b, we got a quarter. So it will be plus a quarter. That is b. So it is a quarter of √2 minus y. Then the value of c is negative a quarter. So minus a quarter of √2 plus y. Meaning that when you integrate now, it will be, it will imply that it will be the integral of 1 over 2, then 1 over y dy plus a quarter integral of 1 over √2 minus y dy plus integral of negative a quarter 1 over √2 plus y then dy. So this is the same as a half ln y, yeah, to be a half ln y. But remember, yes, this was equal to that. We shall integrate also the other side, which had x dx. So this is a half ln y, and this is equal to having a negative here, it will be negative a quarter ln this. Why am I saying negative a quarter? Because if you let √2 minus y to be equal to u, it means that du dy, we shall have some negative here. So that's why I'm saying we say negative. So it will be negative a quarter ln √2 minus y. Yeah. Then still minus a quarter, because this there being a positive here, we shall just say ln √2 plus y, then is equal to, when you integrate this side, will be x squared out of 2 plus a constant of integration. I recommend, in case this work is giving you challenges, because we saw how lns come about while in integration. So this is the same as a half ln y minus here a quarter, we can factorize a quarter. Then I say ln √2 minus y, then of course plus, since the negative is already outside, so plus ln √2 plus y is equal to x squared out of 2 plus a constant of integration. So of course 2 equal signs may not be necessary, so these ones are not necessary. So it means that here I will have since I'm adding, I will have a half ln y minus a quarter. So I can use single natural logarithm ln. Since I'm adding, I will be multiplying these numbers. So √2 minus y times √2 plus y then is equal to x squared over 2 plus a constant of integration. So this is the same as here. I can factorize out a quarter, though here I'm having a 2, but still I can factorize out a quarter so that this ln y also finds this. So if you put a quarter here to create a 2, we shall have 2 ln y. Why have I done this? So that when you multiply, it goes back to a half. So ln y minus, now this one being the same ln, so I will say ln, this is, when you expand this, it will be 2 minus y squared, because √2 times √2, that is 2, then y √2 minus y √2 minus y squared. So we have this is equal to x squared over 2 plus the constant of integration, implying that this is the same as a quarter. Now I can use the same ln because this y, this 2 can come here by laws of logarithms. Ln behave as logarithm, so it will be ln y squared, meaning that you can say, okay, let me show that step. Ln y squared minus ln 2 minus y squared is equals to x squared over 2 plus a constant of integration, implying that that step can be written as a quarter ln, now general ln, a quarter ln, because this is here I'm subtracting, so I will say y squared over 2 minus y squared, so it is y squared over 2 minus y squared, right? Is equals to x squared out of 2 plus a constant of integration. Now, from this point, this is where I bring in the constants. They told me that when x is 0 and y is 1, because I need to substitute for this variable c. So for x is 0 and y is 1, substitute, it will be a quarter ln a half. This will be y, this is 1 over 2 minus 1. So it is ln 1, I guess. Ln 1 is equals to x squared, which is 0, plus c. But ln 1 is 0, implying that c is the same as 0. So when you substitute for the value of c here, it would mean that when you substitute for c as 0, so it will keep the way it is, but without a c. So it means that I will have a quarter ln y squared, of course, over 2 minus y squared is equal to a half x squared, or x squared out of 2 multiplied by 4, multiplied by 4. Yeah, so if you multiply by 4 throughout, I will have ln y squared over 2 minus y squared is equal to, when you multiply by 4 here, you'll have 2x squared. Yeah, so after reaching here, now I'm having this. But how are the e's coming out? With this, now you introduce both sides. So it means that you have y squared over 2 minus y squared is equals to e power 2x squared. When you introduce e both sides, the line goes here. So it means that we shall have y squared is equal to 2 minus y squared, then e power 2x squared, right? Implying that remember, my proof wants me to get the value of y. Yeah, so how do we get the value of y? You can't check the square root at this point because it can't come. It can't come. So what we can do, we have y squared is this. So it would mean that y squared into 1 plus e 2x squared is equal to 2e then 2x squared. But then they told me that x is 1, but I can first get y squared. So y squared is equal to 2e 2x squared over 1 plus e 2x squared. So here it will mean that your y is equal to the square root of 2e 2x squared over 1 plus e 2x squared. So when they told us that at the end that we substitute for x is equals to 1, so when x is 1, y will be equal to 2e squared, because x is 1, so 2e squared over 1 plus e squared under the square root. And that is what the proof just required. Well, that is how it would be approached. Let me do the final question and we see if you can do some exercise. Solve y dy dx is equals to x 1 plus y when we are given that x is equal to 0 and y is equal to 2. So for this case, of course, we are having this one is chap. We are having y dy dx is equal to 2x 1 plus y. So bring the ones of y this side. So we shall have y over 1 plus y. Then dy is equals to 2x dx. So at this point, we can integrate Yeah, we can integrate, and we shall have y over 1 plus y dy is equal to 2x dx, integrate, yeah, but this y over 1 plus y is the same as 1 minus 1 over 1 plus y. How do I get this? Here, you have to use long division. Why? You're dividing y over 1 plus y. When you're integrating these functions, where you find that the power of the numerator is greater or equal to the denominator, you have to use long division. So if you get y, you're getting y and you're dividing it by 1 plus y. Yeah, so if you get y by y, you get 1. 1 times y, you get y. 1 times 1, you get positive 1. When you substitute, you get, because here is 0, so you get negative 1. Yeah, so you're having a negative 1 divided by this, which is not possible. So that's why we are having 1 plus negative 1 over this after using long division. So it implies that this one only, it will be the integral of 1 minus 1 over 1 plus y, everything dy is equal to integral of 2x dx. So looking at this, when you integrate this here, we are going to get y. And when you integrate 1 over 1 plus y, if there isn't this negative, it would be ln 1 plus y, but because of this negative, it will be minus ln 1 plus y is equal to, when you integrate 2x, you get 2x squared over 2, which is the same as x squared, then plus a constant c. But they say that when x is 0, y is 2. So for x is 0 and y as 2, when you substitute these ones here, you're going to get 2 minus ln 2 is equals to 0 plus c. Yeah, so 1 plus 3, sorry, so 1 plus 2, so it is ln 3. Yeah, so it means that the value of c is 2 minus ln 3. So it implies that our function will become y minus ln 1 plus y is equal to x squared plus 2, x squared plus 2 minus ln 3. So having this now, it means that we shall have y plus this of ln, let it come this side. So it will be ln 3 minus ln 1 plus y. So it will be ln 3 over 1 plus y is equals to x squared plus 2. And this is the solution or the final answer. When someone may be wondering after this one coming this side, remember that you'll be having y minus ln 1 plus y plus ln 3. So this is positive, but this is negative. So you are subtracting. So it will be ln 3, then instead of minus, we shall say divided by, because it behaves like a logarithm. Yeah. So this is how you get the answer. Finally, I'm sorry for the background. Finally, we are going to solve the equation. The equation is x squared plus 1 dy dx plus y squared plus 1 is equal to 0, given y is 1 when x is 0. So looking at this, still you can solve basically by bringing these ones this side. So we shall have here, when you separate variables, you have x squared plus 1. Yeah, you have x squared plus 1. Then dy dx is equal to, it will be negative, because it will be negative y squared minus 1. So it will be negative y squared plus 1. The whole of them are negative. So in this case, we can say multiply dx both sides. So we shall have dy x squared plus 1 dy is equal to negative y squared plus 1 dx. Then you separate the variables. So it will be dy over dy over y squared plus 1 is going to be equal to negative x squared plus 1 dx. The negative, I've decided to keep it that side. So when you look at this, now it is changed. Yeah, and the next step will be integrating. So we shall be integrating dy over y squared plus 1 is equal to the negative integral. It would be over, it would be dx over x squared plus 1. So dx over x squared plus 1. This is tan substitution and this is tan substitution because of the nature of arrangement of this function. So this one, the integral is going to be tan inverse of y is equal to negative tan inverse of x, negative tan inverse of x, then plus a constant of integration. But they said y is 1 when x is 0. So when x is 0, y is 1. And what is going to be done? We shall say tan inverse of y. So this is going to be tan inverse of 1 is equal to negative tan inverse of 0 plus c. So this one gives us our c as 0. And when c is 0, it means that if we come back here, our function is going to be tan inverse of y is equals to negative tan inverse of x. Just like that. Yes, so it implies that no. Our c will be not 0, but tan inverse of 1, because this is negative. This is tan inverse of 1, tan inverse of 0. This is 0, so c is tan inverse of 1. Tan inverse of 1. So plus tan inverse of 1. Now, they imply that tan inverse of y is equal to tan inverse of 1 minus tan inverse of x. So tan inverse of y is going to be tan inverse of 1 minus tan inverse of x. This is the same as 1 minus x over 1 plus x tan inverse of this. Yeah, because of space, I would have put it to this side, implying that our y is going to be 1 minus x over 1 plus x. So that is how you would run it. That's how you would run it. I'm giving you some questions members to do. You try your level best and you see what you will come out with. So exercise. Numbers are too many, but I'll give you a few. Sort of the following. 1 dy dx is equal to 4 minus 3x squared, y is 5, at x is 1, 2, y minus 3, dy dx is equal to x plus 3, here y is 4, at x is 0, number 3, x dy dx, x dy dx plus 3 is equals to y minus 4, when x is 1 and y is 13, then 4 x squared plus 1 dy dx is 2 y plus 1 x squared plus x plus 1. When x is 0, y is 3, then dy dx is equal to 2xy at y is 7. When x is 0, maybe 6, dy dx is equal to the square root y over x plus 1, y is 9, at x is equal to 3. So let me look forward to receiving your feedback. And from there, we are going to look at exact differential equations. Then after we go to inexact differential equations, and we shall have moved a step